Okay, now 440 ml of ammonia is oxidized by 1 liter of oxygen. Okay, so this is ammonia. This volume that is being used is 440 ml. This is being oxidized by 1 liter of oxygen. Oxygen is over here. The balanced equation is already given to you. The next part is find the amount of nitric oxide formed and the composition of the resultant mixture. Okay, now here the temperature that is mentioned over here is 800 degrees Celsius. Correct, obviously nitric oxide, this is a gas, and is H2O that is going to be there. Obviously that also is going to be in the gaseous state because the temperature is 800 degrees Celsius. So I'm going to take the first part is going to be the mole ratio. That is what I'm going to take. We are having over here 4NH3 is the balanced equation plus 5O2. This gives me 4NO plus 6H2O. Now here I'm using 440 ml, that is 440 centimeter cube of NH3. So how much of oxygen is going to get used up? That's what we are going to calculate to get the composition of the resultant mixture. The first thing that they have asked is how much of nitric oxide NO is formed. Okay. Now here obviously you can see over here the mole ratio over here. This part is 4 and this part is 4. It means NH3 and NO, the mole ratio is same. So certainly obviously this also is going to be 440 centimeter cube. Okay. Then that is the first part, find the amount of nitric oxide formed. The second part is the composition of the resultant mixture. Now we are using 1 liter of oxygen. 1 liter of oxygen means 1000 centimeter cube or 1000 ml. Out of that, how much is going to get used up over here? 440 will react with how much? I'll take this as X. If I cross multiply this, obviously this ratio is 4:5. So how much I'm going to get for this? This will be 550 centimeter cube. I'm repeating the last part. How did I calculate the amount of oxygen that is getting used up? The mole ratio for NH3 and O2 is 4:5. This is 4 and this is 5. So if this is 440, obviously this will be 550 if I cross multiply this. So 550 centimeter cube of oxygen is getting used up. One more thing that is to be calculated is how much is the steam H2O produced. Now again you can take up this ratio. How much is this? 4. And how much is this? 6. Can you tell me how much is the volume of the steam produced?
60.
This is 4 and this is 6. This is 440. So this has to be how much?
24.
So it has to be 7 na?
It's oral directly. 4 became 5, 440 became 550. So 4 becomes 6. So 440 will become, this will be 660. This is the amount of steam that is produced. Now the final composition of the mixture. This is equal to, this is the amount of nitric oxide formed. So this will be 450 cm cube nitric oxide NO plus 660 centimeter cube of steam that is produced. Now some amount of oxygen is going to remain because we have taken more amount of oxygen, that is 1 liter, which is 1000 centimeter cube. Out of that, 550 will get used up in the reaction because this is chemically reacting. So this much amount of oxygen is going to get used up. So out of 1000, this much is used up. So how much is going to remain? It is going to be 1000 minus 550.
450.
So this is going to be 450 centimeter cube of O2. This is going to be the final composition of the mixture. If you have any questions, you can ask me, or else we can move ahead with the next question.